All right, so today is November 18th, and it is a Monday, and we're going over trig identities, right, ladies? Correct, ladies? Thank you. So we're going to look at reciprocal identities. So you know sine, cosine, tangent, cosecant, secant, and cotangent, right? We looked at it in terms of opposite over hypotenuse, adjacent over hypotenuse, and all that, right? Y'all remember all that when we were setting up side relationships? Well, a sine u is really 1 over cosine u. Okay? If you look at the identity, like sine is opposite over hypotenuse, right? So cosecant would be what? Hypotenuse over what? Opposite, right? So if you're looking at it from a side relationship. So all of these exist, cosecant, secant, cotangent, okay? Cotangent is 1 over tangent, tangent is 1 over cotangent. They're called the reciprocal identities, okay? These are going to be helpful when you start to look at stuff, all right? And try to rewrite or simplify things down. Quotient. Tangent u is sine u over cosine. We've looked at that before, have we not? When we were doing the unit circle, right? We said sine over cosine, which would be what? What was sine? As far as ordered pairs, what was it? No. X. Cosine was who? Y. Y'all remember that? No, I'm pretty sure it's cosine y sine x, right? For sure. You can double check me, but I'm pretty sure. Me and Brian and I had a thought the same. Right? We're pretty confident on that. You want to look at it? You have a circle, look. It's cosine sine. Cosine sine. Yes? Don't look at your nose. All right. So we got tangent sine u over cosine u. Cotangent u is cosine u over sine u. What is u? U could be a what? A radian or a degree?
It's sine is y and cosine is x.
Sine is y, cosine is x. That's what we said, but it's not what you said. You said sine is x, cosine is y. Yes, ma'am.
I think I'm still asleep.
Yeah. Yeah. It's cosine, sine, x, y. All right. Pythagorean identities. This identity right here is probably the most common or most used in trig identities. Okay. Sine squared. Sometimes u could be x, right? Could be whatever, really. Sine squared u plus cosine squared u equals 1. Okay? So, and then you got 1 plus tangent squared u equals secant u. Secant squared u. 1 plus cotangent u equals cosecant squared u. Now, you can also do this as sine squared u is also 1 minus cosine squared u, right? You've got it like this as well. So I could go, okay, sine squared of u equals 1 minus cosine squared of u, right? Moving things back and forth. Okay. Same thing over here. Tangent squared u could be what? Secant squared u minus 1, right? So those are things, if I were you, on my identities, I would write the different combinations here. I'd write cosine squared u equals 1 minus sine squared u. I'd have all 3 of those right there because all 3 of those are the same thing. But if you're not looking at those, familiar with those, your brain's not going to go there. Okay? Same thing for here, as well as that, right? I would write those out and expand them out. Okay? The trig identity, or the Pythagorean identities, are not hard to prove. Okay? I can share that in another lesson, but it's not a bad thing to prove that out. Okay. Any questions on these? So co-function. You remember when we said that the only difference between sine and cosine was a shift of how much? Nope. 90 degrees, right? Y'all remember that? 9? Oh, 90. Okay. So, yeah. Sine pi over 2 minus u is cosine u, tangent, secant, cosine, cotangent, cosecant, right? Those will be more of a evaluation type stuff between what domain would this exist for all tree functions, right? And we're not going to go too far down that, okay? Even in odd identities, even in odd. In Algebra 2, you learned this. If you got f of x equals something, right? If f of negative x equals f of x, then you have an even function. Okay. If you do, then you have an odd function. Now, y'all remember this right here? Some f of x, if you plug in negative x and get back out the original function, then you've got an even function, right? If you have the f of x, you plug in negative x and you get out negative f of x, then it is an odd function, right? Y'all remember that? Should have done in Algebra 2, even and odd, right? Yes? Now, you can teach it two ways. Algebraically, which is that way. Or you can look at it like this. X1 and X2 give out the same y's. I mean, look at it. Negative x and who? X and negative x. So X1, X2. Basically, a quadratic, if its vertex is at the origin or on the y-axis, then it has it's an even function. Right? If this one, it would be like if you got 2 points, when you plugged in negative x into it, evaluate it, and you got out the same numbers but different signs, then it would be odd. And of course, the combo of positive, negative, and all that stuff still applies on that, okay? So just know that you've got, that's why when you go cosine of u equals cosine u, secant of u equals secant. Those are even functions. I mean, if you think about it, look at a cosine. It looks like this, right? Right? Egyptian, right? Something like that. So that's where all that comes from. Y'all ready? So all of what we're about to do next has to be in our own separate sheet paper. Okay, because these right here, you need to refer back to these identities. So let's go have a little fun. Y'all heard me refer to math as like kind of like national treasure, right? The movie National Treasure. That's how I approach math. And it really becomes prevalent in the higher level math, okay? Because it's all dependent upon what you understand, what you see, okay? So you need to look at these 4 problems, and you need to identify who they are. What could you simplify it down to? What could you take sine u over cosine u and say it's this, boom. Or could you say 1 over tangent u is this, boom. It's like a one-liner, right? Correct? So what I'm going to do is give you about a minute, minute and a half to well, copy it down, 1, and then 2, do it. All right? Go. All right. Okay. I think that's working. Yeah. Make sure that is working. Okay, here we go. Yeah, it's working. Sine u over cosine u, we could rewrite that as what? Tangent u. If you look at the reciprocal identities, that's where you'll pull it from, right? All right, so let's look at 2. 1 over cosecant is what? Sine u, right? 1 over tangent u is who? Cotangent u, right? 1 over cosine u is what? Secant u. Now, Palmer, how are we going to remember which one goes cosecant or secant? You don't put 2 cos together. All right? There's no cosecant and cosine, no. Sine, cosecant, cosine, secant, right? Each one of those belong to a different one. Right, any questions on those? Good? Yeah? So you got your treasure map now called identities? Yeah? So before we do this, I wanted to show you something because I referred to it back earlier. So I want to look at I'm going to have this link up on Canvas. And it's Chapter 7, Section 1, Exercise 1. What did they get? Tangent u, right? So it's going to have, now, okay, this was just a one answer, right? It was just a boom. There wasn't anything to work out, right? But as we progress along, the ones that do need to be worked out, guess what's going to happen? It'll work it out. And look right here. This is really cool. You got all of them down there. You can make them bigger or smaller. And they'll tell you when they'll be available. 4 p.m. to who? Midnight. Right? So, and they only come on at 4, so they work an 8-hour shift, right? Of sitting online waiting to answer problems based off these textbooks, whichever textbook that you may be using, calc or pre-calc or whatnot, right? 6 million students, that's pretty cool. Because sometimes you get to these things and it's like, crap, what am I going to do, right? How am I going to get to where I'm going? Here's the, if I would go to exercise 3, which is problem number 3, right? And we got what? Cotangent. Let's just take here, grab one like, I don't know, 45. Let's just, for granted, I want to show you something.
Oh.
All right, so do you see what I'm talking about? So, you know, I always told you, look in the back of the book, right? For the odd answers, everything. Well, they stopped doing that because they figured out with this thing called the internet and technology that they could save some paper. And when they save paper on printing, guess what that saves? Tree. No, we plant more trees. All right. So it doesn't give a descriptive explanation on how they solved it, right? It's just step by step, correct? Equals to done, right? Yes. Okay. So that's beneficial. That link will be up. It'll take you straight to the correct textbook that we're using. Okay. And I think this one's 8 because they don't have them for the lower. What we have is 6, but they're identical problems. Okay. The difference between 6th edition and 8th edition is one, the cover
And the color.
and more corrections on problems that are wrong. Well, people do this, and when they do this, you think about it, you're editing the whole textbook. What's the chances of you getting something wrong? Right? Yeah? So that's why they do additions. And two, they like to sell. You know, everybody likes the new one, right? It's flashy, it's shiny. So anyway, there. All right, so I'll let you do these. Okay. I'll give you. There's 6 of them now, right? Correct. So what will I do? Let's see. I'll give you 2.5 minutes. Is that okay? All right, ladies and gentlemen. 1 plus what is cosecant squared u? What is it? It ain't cot. It's cotangent. Please don't say cot. Cot is something that people bring in for you to sleep on if they don't have a bed for you. It's a temporary sleeping arrangements for the night. No. 1 plus tangent squared u equals what? What? Okay. Please do not make fun of the trig. Yeah. One would hate for me to have you write it out instead of abbreviate it because you're being too funny of trying to make fun of stuff. So what is this one? Thank you. Secant squared u. All right. Okay. Now, what about this? Oh, what's this one? Cosine? Cosine u. Thank you. Does that make sense?
Yes.
Yeah. Okay. What about this? Secant? Okay. All right. What about? Ooh, cosine of negative u is just cosine what? Because cosine is what type of function? No, even. It's like a parabola, right? Quadratic. Remember? Not like that. That's absolute value. I lay the hands out like the Egyptians. All right. Huh? Teacher bro. All right. Tangent u. Tangent negative u is negative what? Thank you. So, any questions about said word problems? How are we doing? We're hitting the surface, right? All right, go.
What's
I just told you not to let it get harder.
Let's go. You got 1 minute. Go. Okay, ladies and gentlemen, anybody else think they got it right? Okay, first off,
Oh, never mind.
I have sine x, cosine squared x, sine x, right?
Yeah.
Okay. Where have you seen cosine squared x? Pythagorean identities, right? So listen here. Can I do this? Can I factor out a sine x?
Yeah.
Why not? See, if I can get it cosine squared minus 1, then I can rewrite it as what? What can I rewrite it now as? Sine of x times sine what? Squared x, right? Correct? Which in turn would give me what? What's a sine x times sine squared x? Sine cube x.
So wait. No wonder not.
So we just rewrote all that stuff up there. We simplified it to sine cube x, right?
Mm-hmm. Oh.
Excuse me. What y'all confused about? Okay, so you need to look at this. See the square up there? That should lead you to an identity, right? Pythagorean identity. One of the 3 you have. And then the variations there under those, right? You got to find something in order to write it. If you look at that and go, man, I got cosine squared. Man, that's a, I got a sine here and a sine there. I can factor out a sine, right? Okay. So I pull out a sine, at least with cosine squared x plus 1, right? Or minus 1, right? Which is who? That is really who? Sine squared x, right? No, ain't no yes, it is. Well, so let me give you a public service announcement on this. If you are checking your phone more than you are checking the board, you're probably going to miss something. If you're texting on your phone while we're talking on the board or looking at stuff or not paying attention to what I'm doing, you're going to miss something. This stuff is the hardest stuff that you'll do in tree. Because you just can't look at it and go, huh. You gotta have some, you gotta see what you can't see, right? Which is crazy. That's why I call it national treasure. When I factor out sine x from both of them, right, that's factoring out. So I factor the sine x, it was in both of them, right? Pull that out, it leaves me with cosine squared x minus 1, right? Where did cosine squared x minus 1 come from? Well, that was on those Pythagorean identities when I said, please rewrite the other two possibilities of those for each one of those. Yeah. You remember I said that? Yeah. That was in between your conversation. None of you think that was in between. Okay, but you got to go back and look at it. These things are not going to scream at you and go, holler, right? You've got to do this. Now, here's what I need for you to do tonight. I need you to look at these. Make sure you, especially the reciprocal identities, right? And then the Pythagorean identities, make sure that those are well versed as far as you know all the different looks of those. That's going to be critical when you move forward. I'm available during the day.